Okay, in this video, we're going to do 25 through 32. I'm going to start with number 25. For 25, we are asked about for 25, we have to find the average rate of change in hours of daylight per month from January to April. Normally, when you see tables, you see that the left-hand column is X, the right-hand column is Y. So if we're going to find the average rate of change, that's just a formula. The average rate of change is just like the slope formula. Normally we have f of x2 minus f of x1 over x2 minus x1, or you can just call that y2 minus y1 over x2 minus x1. The problem is we don't have numbers for our x values. So in this case, we would have to call January 1, February 2, March, April. And so if we're talking about the average rate of change from January to April, our x1 would be 1 and our x2 would be 4. So our y1 and y2 are then decided for us. So we're going to plug in those numbers into my formula. So y2 is 13.9 minus 9.4 and 4 minus 1. Now in this case, since we're going from January to April, that would be our x1 and that would be our x2. The reason being is when you type this in, make sure you have parentheses, this is going to be a positive 1.5. It's going to be positive because it's going up, it's increasing, and the average rate of change could be negative, in which case that would mean it's decreasing. We have to interpret what this means in the context of the problem. So this is my numerical value. Now to interpret it, we have to say kind of what does that mean? So let's put a label on this, even though we don't have to right now. We do have to interpret it and the label will help. Since your Y numbers are hours and your X numbers are months and Y numbers are on the top and X numbers are on the bottom, that's going to be 1.5 hours per month. And so to interpret it, if you have that label, the interpretation is a little bit easier. That just means that it's going to increase an average of 1.5 hours per month. So we can write it increased. And I say an average because it's the average rate of change. It's not an exact linear increase. It doesn't go up by the same amount. It increased an average of 1.5 hours of daylight per month from January 1st to April 1st. April 1st. So 2 points, 1 point for the average rate of change, finding that numerical value, and 1 point for interpreting it correctly. Now, number 26, again, this is only a 2-point question. So what we have to do is solve algebraically for x, and we have a fractional equation. A fractional equation is one of those must checks. So the fractional equation just means, the check means, are my answers okay? So the only numbers that are not going to be okay are numbers that are going to make my denominator 0, which will make my fraction undefined. What I'm looking for is, as long as I don't get -1 or 0, my answers are okay. So let me start. I'm going to find the LCD of the problem because I want to cancel out the denominators. An easy way to find the LCD is to find the product of all the denominators. Now that looks weird because I have a 2x, an x plus 1, and a 4. So what we can do is we can just shorten that up. Instead of a 2x and a 4, we can just call that 8x. 8x could be your LCD. Now, some of you might be thinking, well, you don't really need an 8x. Because 2 goes into 4, your LCD, your lowest common denominator, is actually a 4x times x plus 1. So I'm going to use this as my LCD. Now I'm going to multiply both sides of my equation by that LCD. That's going to go over 1 because I want it in the numerator to cancel out the denominators. So I'm going to distribute. I'm going to distribute that whole chunk, 4x times x plus 1 times 7 over 2x. And I have a minus and I have a minus. Now I'm going to distribute that whole chunk times 2 over x plus 1. Now on the other side, the same thing, 1 over 4 times 4x times x plus 1. I wrote it out this way just to show how things cancel a little bit easier. That 2x is going to cancel the 4x with the leftover of 2. Multiplying all of that together, and I'm going to get 14 times x plus 1. X plus 1 cancels that x plus 1, but be careful, you have a negative here. So we have a minus 8x. On the other side, this 4 cancels that 4. So you just have x times x plus 1. So I'm just going to distribute, combine like terms and see what happens. 14x plus 14. Distribute here. Since you have a quadratic, since you have an x squared, you want to keep the x squared term positive and move everything else to that same side. I'm going to combine my like terms over here. And move this 14, move this 6x. So I have x squared, 1 minus 6 is negative 5. And now I can factor. You can use the quadratic formula if you want to. I think factoring is easier. What multiplies to 14 and adds up to 5 is negative 7 and positive 2. So my two answers, as I continue to solve, are 7 and negative 2. Again, make sure you check. In this case, my check is just, are these numbers okay? Am I okay? The only numbers I couldn't have, if you recall, are 0 and negative 1, and I don't have either of those. So for 2 points, that's my answer. Now, number 27 is graphing a log question. I'm going to need my calculator on this one. All right, on your calculator, if you have a TI-84 calculator, a newer TI-84, you can just type in math and go up to choice A. So if you press the math button, choice A says log base. And you could just hit enter, and then you can type in your base of 2 and then type in x plus 6, and you're good to go. The problem is a lot of us don't have that. So what you have to use is the change of base formula. We have to change it from base 2 to the common base, the common log, or base 10. How you do that is simply put the log of whatever base that you're trying to take, the log base 2, put that on the bottom. So log of x plus 6 over log of 2 will get you the same thing. So how you type that in on your calculator is just press the log button and type log x plus 6. Close out those parentheses before you hit divided by log of 2. And my graph looks nice. I can see my end behavior. On your graph, it probably doesn't look like that. And we have to include the right we have to include the right end behavior. Since we have a grid, I'm going to show my table of points by going second graph. Okay, so I'm going to see now where the errors happen. That's a good indication that there is a asymptote. So we're going to just write down the points that work. So I'm going to write down -5, 0, -4, 1. I'm going to write down all these points. If there's any more, there's 2, 3. And I think there's one more. Yep, 10, 4. So I'm going to plot those points. Make a nice graph. Get rid of all these little dots. Okay, so I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so -5, 0, -4, 1, 2, 2, 2, 3, 10, 1, 2, 3, 4. So if you draw this as your curve, that is not a good log graph. We do have to show the proper end behavior, which means we have to show the asymptote. The asymptote, I'm going to highlight this in blue, and this, what I highlighted in blue in the equation, is where you get the equation for the asymptote. What I highlighted in blue can't equal 0, and it can't be negative. That's why on your table, all of these are errors. Now you can see where it happens on here because it's an integer. It's an integer value of where it starts. That doesn't have to happen. So how you go about doing that is whatever you're taking the log of, log base 2 of x plus 6, I'm going to set x plus 6 equal to 0. And if you solve that, now you just wrote the equation of your vertical asymptote. So at x equals -6, this is a vertical line. That's like my border for my log graph. So I'm going to label that. And that borders my log graph. It shoves my log graph. It has to be to the right of that. So your curve would have to show that end behavior where it doesn't touch or cross your asymptote and it continues down forever. Notice the arrow. Then we would also label f of x log base 2 of x plus 6. That's a perfect log graph for 2 points. Let's move on to number 28. We have tan terminates in quadrant 3. Determine the value of cosine. So initially, what I don't want to forget is if we're in quadrant 3 and all students take calculus, in quadrant 3, my cosine is going to be a negative value. So don't forget to put that negative sign on your answer. All right, so we're going to draw our angle terminating in quadrant 3. When you draw your triangle, it always goes up to the x-axis. We would have that reference angle right there. We don't need to find the reference angle. We're not looking for like a 30, 60, 90 or anything like that. We just have to determine the ratio of sides. So what you need to recall is SOHCAHTOA. SOHCAHTOA. We're given the tan is 7/24. So 7 is the opposite, 24 is the adjacent. Looking at my angle here, 7 is the opposite, but since I'm going down, my directed distance is going to be -7. And my adjacent is going to be a -24 because I'm going left. Now, when you divide -7 divided by -24, it does equal positive 7/24, so that tracks. Now we just got to find the cosine. Cosine is adjacent over hypotenuse. We have to solve for the hypotenuse. That's what we're looking for. In order to do that, we're going to do a squared plus b squared equals c squared. So we're solving for c. C is a hypotenuse. It's always a hypotenuse. type that into your calculator. Make sure you have parentheses around each of those negatives, and then we'll square root both sides to get 25 as C. So that means my hypotenuse is C. Your hypotenuse is always a positive number. Now my cosine is adjacent over hypotenuse. So my cosine is adjacent, -24 over hypotenuse, which is 25. There we go. And it's a negative value again because I'm in quadrant 3. Now, I'm in quadrant 3, and because my adjacent's negative, my hypotenuse is always positive. Number 29. Kenzie believes that for x is greater than or equal to 0, the reason being is because you can't have negatives under radicals, or else you'll have imaginary numbers. So let's see. She wants to know, she believes it is equivalent equal to that. Justify your response algebraically. Algebraically means you can't plug in numbers. You have to work with x's. So let's take this side and see if we can get it to match that side. We're going to convert each of those to fractional exponents. Remember how we do that is top in, bottom is outside. So the top number in our fraction is inside the radical, and the bottom number in our fraction is outside the radical. So that 7th root of x squared is going to be x to the 2/7 times the 5th root of x cubed is x to the 3/5. All right, so in order to multiply these, I'm going to have to add those. Make sure that when you're doing anything with fractions, adding, subtracting, multiplying, anything with fractions, please use your calculator. 2/7 plus 3/5. Math and trenchers, 31/5. So we're going to have x to the 31 over 35. So don't bail at that point. We do have to show what the other side equals. That's going to be x to the 6 over 35, which is not the same. So those are not equal to each other. So Kenzie believes that they are equal to each other. Is she correct? No, she is not. Justify your response algebraically. I did. All right, let's move on to number 30. For number 30, we have some function divided by x minus 1, and we get the answer. We have to say what the original function was. So what we can do is relate this back to, like, if we take 20 divided by 5. 20 divided by 5 is 4. Well, since 20 divided by 5 is 4, then I know that if I multiply these, 5 times 4 equals 20. That's what I'm going to use here. So I'm going to take this, and I'm going to multiply it by what the quotient was. And when I do that, I'll get the original back, the original P of x. So let me multiply that. What I'm going to do is I'm going to multiply this whole chunk by each of them, so that when I get to this last piece, it's a little bit nicer. So I'm going to multiply that x squared times x minus 1 plus 7 times x minus 1 plus 5 over x minus 1 times x minus 1. All right. And then distribute. We have to just leave this in standard form, which means my exponents have to be decreasing. So of x cubed minus x squared plus 7x minus 7. Now what happens here is this x minus 1 cancels that x minus 1, so we just have plus 5, and I'm almost in standard form already. And there we go. All right, number 31, a recursive. Oh, recursive formula. What do we know about that? That has two parts. The two parts are your initial term. The second part is how do you get to your next term, the pattern. So in this case, we can't just add 3 because then that would be 12. So I'm hoping this is a geometric sequence. So I'm going to divide my second term divided by my first term. 9 divided by 6 is 1.5. We're going to check to see if that pattern works. 6 times 1.5 is 9. Times 1.5 gives me 13.5 times 1.5 gives me that answer. So my pattern is I'm multiplying my previous term by 1.5. This entire thing is your answer, not just that second part. Box in either both or don't box in either. Number 32. We have Robin flipping a coin. It lands up out of 100 times. It lands heads up 43 out of 100 times. So that's 43% of the time. I'm going to need that 0.43 number in a second. She wonders if it's unfair because she's thinking it should be 50% of the time. She runs a computer simulation, 750 samples of 100 fair coin flips. The output of the proportion of heads, which she got as 0.43, is shown below. Do the results provide strong evidence that it's unfair? Basically, is it outside the middle 95? So what we're going to do is we're going to find the middle 95. I'm going to take my mean, 0.499, add on twice the standard deviation, 0.49. Take my mean, subtract off twice the standard deviation, and see what the middle 95 is. When you do that, adding on, I get 0.597, subtracting off 0.401. So I know that reasonable values, plausible numbers, not unusual values, fall between those numbers. Hers was 0.43, and that falls inside that middle 95. So do the results provide strong evidence that it's unfair? No, they don't. 0.43 is within the middle 95% and is not unusual. All right, the next video will have 33 through the end of the exam.